We skip around in Chapter 3 in Math 101 for some reason. So I wanted to start by pointing out in 3.4 that in our book on page 237 there are some graphs that every Math 101 student is expected to know. You should be able to graph these guys without plotting points. If you saw the graph, you should be able to write down an equation for the thing without having to think very hard about it at all. You should know what the graph of y equals x looks like. The function, in fact all these graphs are graphs of functions. The graph of the function f of x equals x. The graph of x squared, the graph of x cubed, the graph of the square root function, the cube root function, the function 1 over x, the function absolute x. That's not the best drawing of the function 1 over x I've ever seen. It's a little short because what really happens is this curve starts to hug the y-axis like that as x gets really close to 0. And as I move farther away from x equals 0, it starts to hug the x-axis out here. The x and y axes are both asymptotes of this function y equals 1 over x. And of course the absolute value function we've seen before. We're going to use those in 3.4 to plot piecewise defined functions. So a piecewise defined function is one whose formula depends on where x lives on the number line. So for example, let's graph f of x here. F of x is given by this formula, but the formula depends on which formula I use to calculate f of x depends on whether x is less than 0, between 0 and 2, or greater than 2. So I'll try to graph that here. Because I know what a lot of these functions look like, I really shouldn't have to plot points. I mean, that's a constant function. I should be able to graph that without plotting any points. I mean, calculating any points. That's the graph of a line, and that's good old y equals x squared. For instance, y equals x squared looks like this, right? But I'm not going to use x squared for all x's. I'm only going to use that graph starting, say, right there at x equals 2. I'm only going to use this part of the parabola when x is bigger than 2. So it's this bit of the curve down to, but not including that point on the parabola. The rest of this doesn't get used. Y equals negative 1, I know what that looks like. It's a horizontal line. But I'm not going to use y equals negative 1 for all x's. I'm only going to use y equals negative 1 over here where x is less than 0. So here's x equals 0. To the left of that, I use y equals negative 1. That doesn't look terribly horizontal, but you get the idea. In between 0 and 2, in between x equals 0 and x equals 2, I should see the graph of y equals negative 1 plus 2x. I'm not going to plot a bunch of points for that. I will plot a couple, though, because that's a line. If I plot 2 points, I'll get a line. In fact, it's a line in slope-intercept form. I know the y-intercept is negative 1. That was the same as that point on that horizontal line. So the y-intercept starts here, and then it takes off with slope 2. Now my graph really isn't to scale, so I think what I'm going to do is graph what this line does at x equals 2. At x equals 2, the line has altitude negative 1 plus 4 is 3. This was 2 comma 4. When x equals 2, the height of the parabola is 4. So the line is going to go up to x equals 2, y equals 3. So I'll try to draw a straight line there. And in black there's the graph of the piecewise defined function. I put an open circle here at x equals 2, y equals 4 because the parabola comes down to but does not include the point 24. I don't use y equals x squared except when x is strictly bigger than 2. There's a solid circle there because this line goes up to and includes the point x equals 2, y equals 3 because when x equals 2, f of x uses the line. I mean, its formula is the line. If I left my graph like that, then the grader would wonder whether I really knew anything about the vertical line test or not. So I'm going to clean it up by getting rid of these other pieces. In practice, I really don't draw these other pieces, but I thought maybe it would make a good example for you, as if this were the first time you've ever seen these. Now it's clear that I've got something there that doesn't violate vertical line test. So for one last example, let's graph a piecewise defined function. Suppose they give me this graph and ask for the function. So I see there's 1, 2, 3, 4 different lines. There's going to be 4 different formulas for this function depending on where x lies on the number line. Like I can see here between x equals -3 and x equals -2, y is just a constant function, y equals -5. But between -2 and 0, y is equal to the linear function that gives me this line. So I've got to find the equations of these lines. I think I've got this one already. Y is just going to be -5 if x is between -3 and -2. And looking at the open circle here and the closed circle there, I want an equals there but not there. Then there's going to be some other equation for y when x is between, this is x equals -2 and x equals 0. So from -2 to 0. And then there'll be another formula when x is between 0 and 2. And between, this is at x equals 2 here and x equals 5 there. And looking at this last line, the open and closed circle tells me that that should be equal and that should be a strict inequality. And it looks like these two closed circles means that I want equals there and there. And the fact that that's a filled in circle means these two lines apparently meet at the point 0, 2. So if I tell the function to use this formula to calculate f of 0, or that formula, it shouldn't matter. So I'll just put an equals on one of these, as long as I don't put an equals on both. That's kind of, would be an ambiguous function, possibly. So I just have to find the equations of these lines. Let's see. These two should be easy because they're lines that could be easily written in slope-intercept form. The y-intercept is 2. The slope of this line is, let's see, it goes to the right 2 and up 2. Its slope is 1. So this line must be, I see m is 1 there. So this line must be y equals 1x plus 2. Because its slope is 1 and its y-intercept is 2. And this line, I see, goes down 2 as x moves to the right 2. So its slope is -1. So that must be y is -x plus 2. And this line, let's see, it goes down 1 as x moves to the right 3. The slope is change in y over change in x. The slope is -1/3. Let's find this line. Let's say here's a point on the line. So I could find this line in point slope form easily. So how about y minus 0 equals -1/3 x minus 5. That's y equals this. And so that's the function. We'll just give it a name. How about g? There's the function I see graphed there. There are lots and lots of equations of lines, but if you're expected to find the function whose graph you see there, then that line has to be written in the form y equals, some expression that depends on x.